here's one of these fantastic problems from Mind Your Decisions, which was worked a completely different way in a very nice, easy to understand fashion. But I did want to show you another approach here. Now, most of the time, the gist of the Mind Your Decisions video was to completely factor this down. You end up with a difference of two squares, and you get something that's very easy to evaluate, rather than just substituting 1 minus root 5 in for x and getting a long, you have to expand a binomial to the fourth power, expand a binomial to the third power, and very error prone, as he mentioned. But it turns out in this particular case, there's a way to solve it with an incomplete factorization, whereas it's a factorization, but it's not a complete factorization. You'll note that you can factor an x out of this part inside the parentheses, okay? But so let's just talk about how you get to this factorization. Probably a lot of you see it, but I'm going to go ahead and go through it. Notice that if you expand this, you'll notice that you get, I'll just write this over here. You get this object squared, and some people can just naturally see this. I'm not one of those people, but you get x squared quantity squared as your first term, right? If you're looking at this expansion, this is working backwards from the answer, so it's not actually the ideal way to teach. But when because of the nature of this type of binomial expansion, you have an automatic 2 in there because these two terms will touch each other twice, right? So you have minus 2 times x squared. All right, and then times 2x. All right, that's the result of what happens. Again, the very first term, when you square it, you get what you're looking for, x to the fourth. But then this is the x, the a minus b is equal to a squared minus 2ab plus b squared result. But notice that when you combine all these guys together, this would be the 2ab part of that expansion. And notice that these three terms combine to give you 4x cubed. That's the part I didn't notice. I never would have thought that. Then, of course, when you square minus 2x, you get plus 4x squared. Okay. So again, it's a form that I wouldn't have noticed. I would have just gone ahead and completely factored it. Okay. But if you happen to notice this and then notice something else clever, somebody a commenter on the website actually said that this given information, x is equal to 1 minus root 5, is a root of this equation, which is almost this guy right here, right? Now I'm going, what? How do you see that? But if you just take a look here, it doesn't take as much imagination as you might think. If you look at the discriminant of this quadratic expression right here, you're going to have the square root of minus 2 squared. Let me go ahead and get that, see if I can get that in there. Minus 2 quantity squared inside. This is the discriminant of that expression. Okay, and then you'll get, let me extend this a little bit. Okay, minus 4. Okay, this is the minus 4ac piece, and there's an understood 1 right there. I lost my marker. Hang on just a second. Okay, there's an understood 1 right here, right? So you have minus 4. I'll dot that with 1, and then times another minus 4, right? Now, some people just notice this. I'm not one of those people, but notice that what is all this equal? This is 4 plus 16, which is root 20, right? Isn't it amazing? Somebody just noticed this. Apparently, there was a big joke. Somebody already knew the answer, But anyway, when you do the arithmetic on this, you get 2 root 5, right? Or this is equal to 4 times 5 right here. But if you take the square root of both, the square root of 4 is 2, and we leave it as root 5 right there. And of course, there would be that's root 5, folks, or root 5. And there would be a 2 in the denominator, and so you would actually get 1 plus root 5 and 1 minus root 5. So anyway, it's not as much of a leap of like what? Where did that come from? But so this person figured out under this factorization and under this setup right here that 1 minus root 5 would actually be a 0. But if 1 minus root 5 is a 0 of this, then x squared minus 2x has to equal to 4 if you just take the 4 over the other side. Isn't that amazing? So you see, that's exactly what he did right here. He just rewrote it, and whammo bammo, x squared minus 2x is equal to 4, and you get 16 for your answer. Now, I talked it to death, but if you just happen to know that 1 minus root 5 would be a 0 of this equation, you kind of notice it mentally without writing everything down like I did, leading to the confusion maybe. But to me, that's very clever to work with an incomplete factorization. In other words, all the kids all the way up to middle schoolers says completely factor. But this was a case where an incomplete or a not complete factorization actually led to a so-called quick solution if you happen to recognize that 1 minus root 5 is a 0 of this equation. All right, y'all, again, that's a little bit of a leap. The way Presh Telwalker did it was much better. He completely factored this, and it came out to be something very nice with a difference of 2 squares. And he arrived at this very same solution for 16. All right, hope you enjoyed it.